Hello folks, well we've got another set from Alan, our mystery benefactor. This time it's a repair for him, and it's one of the more unusual smaller Midlands, and that is the 1165. One of those. March 1991. So at least it's got high-low power, which is more fun for us. I've shown these before. I've got a factory original mic on my own set. My own set is on the shelf in this very room, so it's not in storage. So you know what? If we get this working on the end of the on-the-air test, I can use his mic, and then we can use that mic. I'd like to have a standard replacement mic. I'll see if I've got one, because we don't know what they sound like always when they're factory mics. So I'm just opening it up just to see if there's anything I need to be scared of. No, it's going to be one of those that boots up on channel 9. That's potentially a scary capacitor. Right, we'll get it connected all up. He's also sent an Intech set, so it's not far off being a current model. So that'll be interesting to look at. Power supply on, 13.8 volts, power on, and of course it boots up on channel 9. Might not have to unsolder the meter on this one. A meter? That's the speaker. Right, let's plug this mic in and see whether that is correct. I don't know. Put the signal generator somewhere near. Doesn't sound right, but that's on 100. But that's 0.3 of a microvolt, so it's certainly got the sensitivity. I'll put picture in picture, and then we can look at if it's transmitting together. So I'll go on the 3 watt scale of the test set, and it's doing 3 watts. Of course, it's got the microphone coming out of the side that I'm working on, my right, its left. It's all in the way. Right, let's look at the other channels. Exactly 3 watts. exactly 3 watts. Low power, let's go to channel 20. $250 milliwatts. Back to full power, and the current consumption is 1.03 amps. Let's see if they've got some deviation. Wallow. Oh right, it's like that, is it? Wallow. It's 6.5. That's going to talk on several channels at once. And frequency wise, it is doing what? 27,79096, so it's hardly off at all. We may as well bring that up right away, then we don't have to set the signal drain to low. I like the way the microphone's on a plug and socket. If I can do this in half an hour, we can do a scratchy corner test. I'll do. I'll look underneath and just see if there's anything dodgy. Right, let's go through this transmitter. We're not going to do the VCO because it's not something we're going to need to do, and I don't have a particular instruction to do it, that we could work one out if we had to. Is this wax or is it that nasty glue? Don't know, I'll just put the soldering iron in it. It's wax. Right, so let's go back to the main meter and make sure we're centralised for transmit. So although I'm at full scale deflection, it's still beneficial for me to have it at the 3 watt scale for these. Now we're going to have to switch to the next scale, which is 30 watts. You know, this is the inconvenience of this, because I could do with a 10 watt scale, but it hasn't got that. But business radios in the UK are 25 watts usually, so that's what that's all about. Now, does this have a power preset? I don't know where my other glasses are, we'll have to cope. TX. That looks to be low power. TX meter, signal meter, TX automatic power control high. So I'll set that to full for now, just so we set this PA up. It's doing 4.1 watt at the moment. I don't think that's got a core. We're not touching those because they're going to be needed to run with the spectrum analyzer. That's going to be the 56 meg second harmonic trap. So that's where we are with that. I've just dropped the power now to exactly 4 watts. Wrong tool. It was the right tool a minute ago. That's bizarre. setting that to 3.9. When the set cools down, it will be 4. I'll just see it we're balanced, and then we'll come back to the power later on. So go to channel 40, 3.6, that's not good, and 4. So just see whether we can trim that a bit better. It's not that one that's causing the bother. Actually that one. 3.8. 3.8 and a bit. Channel 20. .9, so that's now right. Just wait for this to cool down. We'll do the deviation. We'll not let it cool down. We'll just do the deviation on this test set for a start. Wow! I bet that made them feel really good when they were transmitting on 3 channels at once. Huayun. Right, let's see what it says on my other test set. Wow, it's a little bit low. Wallow. That's where it should be. Go back to see what the Marconi test set says. Wow, it says a little bit high. So the Marconi test set's lying a bit today, but it was still up in the 6. That isn't. So that fact hasn't changed. The 0.5 difference between this test set and the other is how it is. 2.2 kilohertz to 2.5 peak. So let's do the power meter, and it is that one. So it wants to be in transmit all the bars. I think we're going to set this with the low power switch then. It's supposed to be 1 bar. That one. That's set. Right, we'll have a look at this receiver. It just gives us the chance for it to cool down. So we're now plugged into the sinad meter and all that, and we've still got a daft attenuated speaker I did on Christmas Day. But I can hear it even if you can't. So we'll go to the oscilloscope, and we want to maximise that waveform. Oh, before we do any of that, we need to go over to the sinad meter and see how it's performing. And the answer is very well. So, wow, 0.33. For 10 dBs, 0.28. Midlands aren't usually as sensitive as this, but this is just coming to the end of 2781, where we're moving towards 2794, and we notice it's got a crystal filter in the receiver. For 20 dBs, if it will do it, 0.8. Squelch threshold, and at maximum. Put it to maximum. It's not far out from where I want it. It's 300 microvolts. And the threshold is 1. So hopefully that'll come down a little bit. 1's okay, but it'll come down a little bit if we reduce that, hopefully. Right, where we were, back to the oscilloscope. So our detector is likely to be that one. That was slightly out. Just turn the volume down a bit. There we go. Right, we'll go now over to the cyanide meter and see whether we can get an improvement on the sensitivity. Not that it needs an improvement on the sensitivity, because it's very good. I think the only thing that's happened to this is the deviation's been tweaked up, so it transmits on several channels at once and sounds louder to a fidelity 1000, but breaks anything with decent filtering. It's not being louder, it's getting wider, that's the problem. So we'll set that to about 4 dB, and we'll go through the front end. That looks about where it was. Put a bigger signal on for this one. We're now on the 10.695 IF. That's there. Improvement there. .455 IF. Let's see if we've got a new figure. Will it be new improved? 0.31. Said it was pretty good, wasn't it? 10 dB, 0.26. It's probably got another 1 foot range now on receive. 20 dB, 8.6. That's interesting. Right. Squelch. Oh, we'll do the meter. Do the meter. So the meter's there. We want S9 for what it's worth. It's exactly where it is at the moment. But we'll just tweak it. Especially if we can tweak it back again. I just want it on the edge there. So if we go up in signal, we get the plus 30. So it was already S9, but there's only 4 bars, aren't there? So you can't it was 4 and it's now 4 bars, the same, but it's slightly different 4 bars. Doesn't have a meter lamp. They're okay, they're okay, they're okay. The speaker's okay. Let's do the squelch. I'll take the external speaker off. I don't like the all or nothing volume control, but it's not faulty. See what it sounds like on our proper extension speaker. It does sound a bit thin. Right, back to the squelch. Signal generator off. I'm doing this the wrong way around. Squelch to full. 100 microvolts on the signal generator. I'll put this on the attenuator, then you can see what I'm up to. So we're at 100 microvolts, and we need to increase the squelch, which that's the only preset we haven't touched. So which way is it going to be? That way. Now that's too generous. Now that's too coarse. This is a bit finicky, isn't it? That's bang on where we want it. Breathe on that and it'll change. So back to the other test. Threshold, set squelch threshold, signal generator back on. Hello, come on. Right, we'll try that again. Oh, it's still 1 the same. Well, that's rubbish. Try again. Yeah, you can. Yeah. Got good hysteresis. In other words, the way it follows 0.9. Good. So that's just a retune and test. If you're wondering where we are with the other CB1100, in fact where we are with the 2026 HMV stereogram, the CB1100, I put that back on one side because we're at the stage where I've got thermal runaway on transmit if you transmit more than 12 seconds, and the receive is doing 3 microvolts, which is too lousy. But I don't think it's got an electronic fault per se. I think it's got a duff filter. The snag is, where do I get replacement filters? Now, we've got the crystal filters in stock. I suspect it's going to be the ceramic 455 filter, and I can nick one off some scrap chassis, hopefully. I can't get exactly the type that's fitted, you see, and I probably can for a price. And the other filter, well, I'm absolutely stumped with that one. But that's what I think we're left with. So I can't put so much time into things like that. It's like we've got the Macom still on the back burner. Right, so finally, transmit power. I'm going to keep this at 3.8 watts. This is 3.8 of our watts, so I think that's the safest thing to do. It will be less when it's cold, and it will be more if it was on a higher voltage, like in our car. It's 3.9 there. Where is it there? 3.9. It's 3.9. It's not 3.8. It's 3.9. I just pop the voltage up a fraction. I know it's not our set to do this, but let's just put it to 14.4, which is where our car is charging at. Let's go back to channel 20. Spot on the 4. But we're doing these things at 13.8, so I don't put down. I could turn the power up so it is 4, but I think it's going to take off, and we don't want that. So to become unstable, in other words. So, oh, you know what? We didn't do low power. Or did we? I don't think we did. No, we didn't do low power. It's in lovely condition for 32 years old. I'm also going to look for dry joints. So I'll take the other lid off as well. So I'll go back to the main meter. At the moment we're showing 250 milliwatts. That's 400 bang on. I'll just cut the power. I'll pause the video, I'll have a look at this. Right, so I haven't got a standard replacement mic wired for one of these. If one of these had come in without a mic, of course I'd have to wired one for it. So we're going to have to do the test on the mic supplied, which is not the factory original. It just happens to say Midland. The mic these came with was one of these. It's an up-down mic. It's quite funky, isn't it? It's a bit different. And it has a right angle plug, like that. So I've just borrowed that for the demonstration at the end. That's an electret condenser mic. So we'll carry on with the test, the mic which he sent in. So it's not going to be quite how I like to do it. But there we go. We'll plug that into our aerial, turn the test gear off, and see if you can hear anybody. One niner Roger. Right, well there we are. Nobody on it's receivable, despite it having good sensitivity. I'll just check 1.4. He said the F word, how rude. Right, there you go. Thanks for watching. More unusual Midland from 1991, the Midland 77 1165.